Alright, this is note card number 10, which is on derivative rules. So in the last note card, we talked about the definition of the derivative, which was this big equation here, and we used it to find the derivative of several functions down here. So we used it to find the derivative of that, for instance. There's a lot of algebra that goes along with using this equation, and so once we've done that a few times and we understand how that works, we can kind of move on to some rules that that come out of this definition. So for power functions, there's a set of pretty straightforward rules that we can use. And we saw that pattern in class when we went through a few examples. But basically, if you've got a power function like 5x to the third power, a power function always has three parts to it. It has a coefficient. Okay, so this is a coefficient here. It's got, and I'll write that out, coefficient. It's got a base. And for a power function, the base should be your variable. It should be your x. And then it's also got a power. That's why it's called a power function. Now the rule is fairly simple. You take the power, so you take the power and you multiply it by the coefficient. So 3 times 5 is 15. The base stays the same, so the base stays x. And then you subtract 1 from the power. So we're going to say 3 minus 1 is 2, and so this becomes 15x squared. So if we start with f of x equals equals 5x cubed, then what we can say is f prime of x equals 15x squared. And that's so much easier than going through this whole process every time. So that's going to be a really useful rule in the derivative world, and we're going to call that the power rule. That's the power rule, this one right here. Now, there are a few other rules on this note card that I want to reference. And the first one says that d dx, and this is the way that we say taking the derivative of. It's kind of like an operation. So when you take the derivative of c, and in this case c is a constant, so if you take the derivative of a constant, it's just 0. So the derivative d dx of 7, so the derivative of 7 is 0. There are a couple ways you can think about that. You can think that 7 is really 7x to the 0th power, and if you apply the power rule, 0 times 7 is 0. You can also think about the graph of it. So the equation y equals 7, the rate of change of this function, it doesn't change. It's just 7. So when you find the derivative, which is the rate of change, there is no rate of change for y equals 7. So that's another reason you can understand why the equation, or why the derivative of any constant is 0. So that's 1 and 2. We've got derivative of constant is 0. We've got the power rule. I kind of already, in my example, I actually used the constant multiple rule, which is that you basically, if you have x to the third, and that's 5x to the third, you could also think of taking the derivative of x cubed. X cubed is just 3x squared, and then multiplying that by 5 afterwards. So 5 times 3 is 15x squared. So it's kind of a subtle difference there, but if you want to, if that helps you understand the power rule, then you can think about it that way. And then the last thing is the sum and difference rule, which basically just says that if you've got a bunch of if you've got a polynomial, so f of x equals 5x cubed plus 3x squared plus 7. I can take the derivative of this, and then I can take the derivative of this, and then this. And for the sake of, why don't we assume that this is a positive and this is a negative? So let's just go through and see how this works. If I took the derivative, so I find f prime of x of this one, I'm going to use the power rule, same way that we did before. It's going to be 15x squared minus, and then I just do this one separately. 3x squared becomes minus 6x, and then 7 goes away. So the final answer would be 15x squared minus 6x. So basically, if there are multiple terms, you can take the derivative of them separately. And you're going to see that a lot. All right, moving on to the examples here. The first one is an AP question. It's got stars next to it. What you're going to notice about some of these powers is they are fractions. So the thing that you want to be sure to do when you're trying to find the derivative of one of these is make sure they're in the form coefficient, base, power. So this one is in that form, and so I'm ready to take the derivative. I'm going to take the power, multiply it in front, get 3/2 x to the 1/2 power, and then it says find f prime of 4. So this is f prime of x. Let's find f prime of 4, so I'm going to plug 4 into this. 3/2 times 4 to the 1/2. 4 to the 1/2 power, well, that's just the square root of 4, so this is the same as saying 3/2 square root of 4. Square root of 4 is 2, so we've got 3/2 times 2, which is just 3. So the answer here is 3. Get rid of this. For 2 to 3, for 2 and 3, differentiate each function. So we've got the function equals 1 over 2. This is a little tricky. What this is saying is it's 1 over 2 times the cube root of x squared. Now, this is not in the form coefficient, base, power. So let's get it in that form. The coefficient in this case is 1/2. You can see that right here. So our coefficient is 1/2. I'm going to change this radical notation into rational exponent notation. So another way that we could write this is 1 over 2 x to the 2/3 power. And that kind of draws on your understanding of exponents. And then I don't like that this x is on the bottom of the fraction, so I'm going to change that. I'm going to go ahead and change that to 1/2 x to the negative 2/3. And remember, we can move a base up to the top of the fraction by making the exponent negative. So now we've got this in the form coefficient, base, power. I'm going to write that over here. 1/2 x to the negative 2/3. And that's what you're going to want to do anytime you're using the power rule, is get it into that form, because it's going to make it way easier to take the derivative. So if this is f of x, then f prime of x equals negative 2/3 times 1/2. That's negative 2/6, which is negative 1/3. So negative 1/3 x, and then if I subtract 1 from negative 2/3, I get into the negative 5/3 power. So that's the derivative in number 2. Number 3, a of t equals negative t to the 4th over 2 plus 3t cubed minus 2t. Again, the only term that I'm really worried about is this negative t to the 4th over 2, so I'm going to change that slightly. I'm going to change it to negative 1/2 t to the 4th, and then we can take the derivative of each term individually. So a prime of t equals 4 times, so 4 times negative 1/2 is negative 2t cubed. And then if we take the derivative of that term, we get plus 9t squared. And then if we take the derivative of the last term, it's minus 2. So that's the derivative in number 3. And then our last problem here, this is just another way of saying find the derivative, d dx. Sometimes you'll see dy dx, find dy dx. This is the same thing as that. And one way you can think about that is this is likely a function and could have been written as y equals 1 over x cubed minus 1 over x plus x squared. So this whole thing is y. So instead of writing it dy dx, what they've done is they've taken the y, which is this whole function, and they've put it right here. So I guess what I want you to see here is that dy dx, if they gave you the function and then said find dy dx, this is the same thing. They're asking the same question here. It's just that they're actually writing what y is. So this is d, and then here's y dx. Great. Okay, so once we understand that they're asking us for the derivative at a point, so at x equals negative 1, we're going to take the derivative and then plug in negative 1. I'm worried about a couple of these terms because they don't look like they're in the right form, so I'm going to change this to x to the negative third minus x to the negative first plus x squared. That's what my function is. And then I'm going to take the derivative. So I'm going to get negative 3x. If I subtract 1 from negative 3, I get negative 4 minus, and then negative 1, I'm multiplying negative 1 out in front, and so I'm going to have a negative times a negative. So it's going to leave me with plus x to the negative 2, and then plus 2x to the first. And now I'm going to plug negative 1 in every place I see an x. And so the result of that is negative 1 to the negative 4th power. Let's rewrite this. So we've got negative 3 times 1 over negative 1 to the 4th plus 1 over negative 1 squared plus, and then 2 times negative 1, that's just negative 2. Now, in this first term, we have negative 1 to the 4th. A negative 1 to an even power is going to be positive, so we get positive 1. And then the same is true in this case. Negative 1 squared is positive 1. So in the end, we have negative 3 times 1, so that's negative 3, plus 1 minus 2. Negative 3 plus 1 minus 2 is negative 4. That is our final answer. That is the derivative of all of this at x equals negative 1. That's the power rule. We're going to use this a lot this year, so I really recommend you practice this until you're comfortable with it. And probably one of the things that you're going to have to practice along with just that basic idea is using your exponent rules to manipulate these expressions into forms like this, where you can actually see the coefficient, the base, and the power. Because once it's in this form, it's really easy to use the power rule. And so manipulating an expression like that into this form is just as important as actually understanding the power rule itself. So make sure to work on that as well.